Good morning. So, thanks for joining. My name is David Agnew. I'm going to run through a presentation for you on the path to putting autonomous test vehicles on roadways, so autonomous ADAS vehicles. So the reason behind this is there's a lot of stakeholders in the space of ADAS and autonomous vehicles, and if you're in the space, there's a strong chance that you're going to need to put a vehicle on the road. And what are the challenges with doing that? So the engineering effort in doing this is not trivial, and there's definitely safety hazards that are important. So what I want to do with this session is give an overview of the basic steps, but a key message is, because we've been doing this for the last 10 or so years with a strong focus on autonomous, there is a process that's starting to show up, and there's a lot of services and products that are available to make it much faster than what it used to be, much less cost and safe. So real quick background on myself. Why do you want to listen to me on this, which is a good question. So I've been 34 years, started out in aerospace. Most of that's been in automotive. Over the last 10 years, I headed up advanced engineering for ADAS and autonomous for continental North America. I also headed up advanced engineering for autonomous for Hyundai Mobis North America. Currently, I'm at Dataspeed, heading up business development for a new autonomous product. And at Dataspeed, we've got over 100 customers that have over 500 of our vehicles outfitted with our ByWire and different products out on the road currently. So I'm going to break this into 15 items, 15 steps. They don't necessarily have to be in this order, but it's an order that makes sense to me. And I promise to go through it quick. I tried not to make this a boring thing. I want to make this something that can be gone back to as a reference. And I think we'll make this available on our website as well, just as a reference process. So, getting started. Item 1, the safety approach. This can be the biggest hurdle that stops people from going into it or stops companies from going into putting it on the roadway, but it can also be the biggest failure point. It can be one of the worst things that can happen if it's not done right. So what are the basics here? The mindset is a key thing. What you really want to do is avoid all unnecessary risks. The second item is, this really is an engineering problem. Now, it's engineering companies, it's engineering departments that are doing this. You've got to take an engineering approach to it. That means define the system that you're going to put on the roadway. Not just the technology that you're testing, but how you had that test vehicle set up. Who's driving it? How have they been trained? What are you doing to mitigate any of those risks? And you do an analysis then on that setup. A safety analysis of either an FMEA or a fault tree analysis. Very good methods that have been around a long time, and they will give you results that show you where there may be problems. Based on those results, you create safety measures. We're going to train our drivers this way. We're going to have a monitoring system for our safety drivers. We're going to have overrides. The last thing you do then is you verify those safety measures. This is state of the art, and it's very simplified, but this is the basic outline for how you address the safety side of operating a 70-mile-an-hour vehicle on a roadway without having your hands on the wheel. The thing that's always present here that you want to be prepared for is the rare events. And that's what everyone wants to think sometimes, that I don't have to worry about something that is a very low chance, but that's exactly what you do want to prepare for. Good news is there's a lot of help out there in this space. On any of these analyses, the plans to have somebody check, there's services that are very good, very experienced that can help you along the way. Item 2, policies and regulations. Depending on what region you're in, what country, you have to check into that quickly for the US at the federal level. A key item is Department of Transportation, NHTSA, puts out a guidance that is currently on version 4.0, specifically for testing autonomous and ADAS on roadways. It's a good source. Depending what state you're in, you need to check your state level requirements. Each state by state, they have different laws, and that's because the states have the authority for what they do on the roadways. NHTSA, the federal level, they have a nice tool that's currently been updated to include a summary of all the states and their laws. So example, you click on Michigan, it pops up right to the latest regulations that they have in place. Great source for checking that, because it's very hard to keep track of all this. And again, there are sources, different groups that you can go to get assistance with this. Item 3, vehicle selection. Can everybody hear me okay? Okay, good. So vehicle selection seems like a very basic item, because that's part of your product, it's part of the image, but you want to ask a couple of real key questions with that. Is the first one, is there a ByWire kit already available for that vehicle? If there's not, when you go to get that access put into it, it's going to take much longer, cost much more. It's almost an order of magnitude, but it's more like about 5 times more. It's multiple months, hundreds of thousands of dollars, usually to convert a vehicle that does not have any ByWire capability to where you can access it. Plus there's risk involved in doing the development. What production safety features are built into that vehicle is also a key question. Does it have ADAS safety features that makes your vehicle in your testing process safer? Pedestrian detection, emergency braking, automatic emergency braking warnings. The key thing here is there is a lesson learned out there with Uber's testing. I'm sure you're aware of. If you're not, look it up, because we have to keep learning from each other's lessons as we go along. But we don't want to look at those ADAS features as getting in the way of what you're developing. You want to look at those as keeping your vehicle as safe as it can be. Item 4 then is the ByWire Controls adaptation. For the steering, braking, shifting, acceleration, if you're going to do autonomous or ADAS, you need to have access to those controls with electronic signals. This enables your autonomous driving, teleoperation, flexible controls. You can control the vehicle with different types of controls. And this is also where your primary safety measures reside while you're testing. Imagine your test driver's in a vehicle, it's going down the road 70 miles an hour, and the software is driving the vehicle. It's development software. All of a sudden it starts to turn to the right at a fast speed, the fastest the software can. The safety driver has to take over before something bad happens. How fast the software can react or drive the vehicle off, and the setting that it takes for the safety driver to be able to take over it resides within the ByWire system. So it's your primary safety mechanisms. Some of them are in the ByWire. Many vehicle kits are available for these. There's different companies out there doing it. Dataspeed is one of the global leaders in this space. We've got, I think, something like 15 different platforms now, from small neighborhood electric vehicles all the way up to full-size pickup trucks, SUVs, sedans, everything in between. They're all listed on the website. We've got a reputation for reliability, and we've been certified for safe operation even in the European roadways. Item 5, power and electrical architecture. So this is connecting everything together. You've got your computers, sensors, the ByWire system, your data logging. There's a lot of electrical equipment that's going into your vehicle, some of it very high-powered computing. So you need to think about, how am I going to manage all of the power to these so I'm not blowing things, blowing fuses, starting fires, having outs. So what you want is something with smart fusing, multiple channels, things that you can control, and have some intelligence behind how you power up all these systems. Again, there's some purpose-built units available there. Dataspeed has, we're on our 2nd generation of this type of device, purposely built just for running complicated electrical architectures in a vehicle. Item 6, the sensors and perception. This item I'm not going to dwell on because it's obvious you're out there doing ADAS and autonomous. There's a suite of sensors that are needed that's part of that product. You also may be selecting sensors for the data acquisition, ground truth, different information that you want to get during the testing. Key thing is there's hundreds of choices out there on the cameras, LiDARs, ultrasonics, whatever you're using, especially the LiDARs. Mostly the LiDARs. I think there's still over 60 LiDAR companies. From lessons learned, on the LiDAR side, the pricing, the reliability while it's operating out on roadways, and its availability, those have been challenges in the past. They've been roadblocks in the past. That, on all of those, is improving, especially with some of the companies. So you really want to take a good look at those particular features. It's not just the performance, it's do they actually work, and then do they work when you're out on a roadway environment. Localizations and maps, key part of the testing and the development. A very key technology here is the GPS, more correctly, the GNSS. And what you want to look at and be aware of is the GNSS with RTK correction. Real-time kinematics. What that is a correction that's done by a regional tower that then sends out a signal, a very low-level signal that can be picked up with LTE communications. That correction gets your GPS down to just a couple of centimeters of accuracy. The reason that's important is you can do a lot of functionality, a lot of data acquisition that's important for ground truthing with this technology. Key thing to share here is that technology, the GPS with the RTK, 5 years ago, to install that on a vehicle with the latest features, $30,000 to $40,000 just for that bit of information, just for that capability. That's come down dramatically now. It's getting down into the thousands of dollars. So it's something you want to put on your list to take advantage of because it's very capable. Maps. There's also many options out there to have that stored in your memory or to be streamed into the vehicle. Again, for part of your data analytics or just to have part of a demonstration. Communications for the vehicle is item number 8. And this is how does the vehicle communicating to the outside world. So your V2X functionality that you may have in the vehicle, data logging that you may be doing remotely, monitoring of how the vehicle is operating, remote monitoring, and also teleoperation of the vehicle itself. All of this is done with some type of communication devices. The main technologies out there right now that are being used that I know of are the Wi-Fi type systems and LTE, cellular. On the LTE side, primarily 4G is what's being used. 5G is underway and being put out there, and 5G it's really an order of magnitude increase. 5G is allowing it's essentially allowing video level of data streams to be sent in real time without interruptions. Key thing with 5G is it's deployed now in some specific areas, test facilities, some pilot sites, and it's just starting to be rolled out across the country in the US, but it's going to be like a 2, probably 3-year process before it's everywhere. It's definitely coming though, so you want to put it into your planning as you look down the road. Key item on what's available right now with LTE from a bandwidth reliability standpoint is the latest version allows for carrier aggregation. You'll see the term CA. Carrier aggregation allows you to tap into each carrier that's available in the site that you're operating in. So AT&T, Verizon, another one that's available. With aggregation, you can connect to all 3 of those and increase your bandwidth and have all of them operating at the same time in real time. So it costs a little bit more, but if you have the need for that extra bandwidth because 5G is not there yet, it's available, and it does work. A lot of commercial units out there by multiple companies that you can utilize. You can also If you're doing that path and you have to go through the cloud with your data logging or your monitoring or video streams, there's also options now to have a streamlined path through the cloud. There's different names for that. The different services have their own trade names, but if you look for it in terms of, they call it slicing or MEX, it will get your delay times down to 10 to 15 milliseconds going from cellular to the cloud back to your device, 10 to 15 milliseconds. Pretty amazing stuff. Item 9, your computing hardware. So you obviously need computings. You're going to be selecting either CPUs or GPUs depending on how your autonomous is working. A key consideration here is, and I'm not going to go into all the details on the computing, but is use of ruggedized product. I think this is being learned by a lot of companies when they first jump into this, a lot of institutions, is a desktop PC, you mount that into a vehicle, chances are it's not going to last too long, or you're going to have problems and you're going to be troubleshooting things. So ruggedized product is available by several good companies. Also, how are you mounting it? What's its accessibility? And what are the cooling needs? Key part, again, if you're doing a lot of processing. Item 10, obviously, is your data acquisition. Not going into a lot of detail here, but key considerations are your data logging equipment. What are you using to access directly to the raw data signals coming from your LiDAR, your radar, your cameras? And then the second key part is, how are you managing the logging of all of this and capturing it and doing the smart capture of it? There's a boundary between those two items, and it used to be you do your rough capture inside the vehicle, and then you would take that and load it up into a mainframe, send it to a cloud. But there are now systems that are much more effective at doing some of that transfer from the vehicle over cellular to your cloud site and having intelligence built into that transfer. So talking about a lot of data here being transferred, a lot of complexity to it. Again, there's good companies on both sides of these two different problems. The direct data acquisition from the devices, and then the smart management of the data that you're logging. Item 11 is the automated driving software. Again, this is very basic because a lot of companies in this space, that's what they're developing, so they don't need to consider somebody else as a source. But a lot of institutions, government institutions, research projects, they're just looking for something that functions so they can study other things, the human interface. There's many open source options available for this. I'm listing 3 of the key ones here that have a lot of activity. AutoWare, Apollo, OpenPilot, there's others. The Pro here, it's low cost, it's easily accessible, it is expandable. You can do your own software on top of it. Drawbacks are that it does require integration. You still have to take that software and integrate it yourself into a vehicle with all the communication sensors. And it does have limited capabilities. It's wherever it's at right now in the open source community. So there are also, second option, commercial algorithms available. Several companies in this space. The positive here is you can select what you want. It's integrated and proven at an operational level, so it's ready to go out of the box. Can be a quicker path. So again, I'll mention here, Dataspeed's one of the companies in this space. I'm only showing a few of the algorithms that we have out of the box, ready to go, that can be plugged in and start operating day one in a new vehicle. Item 12, very basic again, but you got to put it on your plan as your functional checks. You build and integrate everything into your vehicle, but before you go out and start spending all the time with your test vehicles and your test people, is you got to make sure everything works. You got to test it before you actually start your testing. Item 13, key point. And this is one we get a lot of questions on at Dataspeed with a lot of the companies that are just getting into this space with autonomous operating roads, operating vehicles on roadways. How do they go about making sure they have the right things in place with their safety driver? What you really need to be concerned about is what are the minimum capabilities that you need to have? What's the required training? And then how do you monitor and keep track that their performance is good and give them the feedback while they're operating? The good news here is there's a very good guideline that's been put together by Society of Automotive Engineers. It's a guideline that's open for everybody. You can go to their site and purchase this. It's been put together over the last several years in the space with companies that have been already deploying people. It's really a good tool to access, and I highly recommend, if you're going to be putting anything out on the road with your safety drivers or other safety drivers, utilize the guide. Item 14, only 2 more left here. Item 14 now is the safety verification. This is not the verification of the product that you're testing. This is the verification of how you're going to test it now out on public roadways. The safety measures back on item 1 that you determined you needed and that you added because of your safety analysis, this is where you're going to be checking those and making sure that they work. So your ByWire system overrides. You buy a ByWire kit from a supplier, they put it into your vehicle. You want to make sure that that's been tested. The Dataspeed will actually run through, do those testing, give you the results of them. Safety driver reaction. You want to make sure that your safety driver is performing correctly and that it matches with what your ByWire system is doing. Have they completed the training? You want to audit that, do a check in the box. Do you have a safety driver monitoring system that you've put in your vehicle? This is a recommendation now from the National Transportation Safety Board, another federal government agency, based on the Uber incident, that they have a monitor, automatic monitor built into your vehicle that watches the safety driver for distraction or drowsiness. If you have that in your vehicle, verify it and make sure it's working. Item 14 is the verification of all these safety measures. Last item then is certifications, approvals, notifications. This is going back to the mandates or regulations that are in your region. Some of those mandates are going to require certain things. If there's a certification, and these are primarily in the European countries, you need to go through those, get it certified. If there's approvals or notifications, some of the states in the US, they have specific rules. You need to go through this and make sure that you put them all into place. An example is in the state of Michigan, you don't have to give notification for a lot of different autonomous type testing. If you're going to do platoon testing, there's a rule in there, you have to give notification to the regional authorities. So this item 15 is your last check in the box. The key thing here is you don't want to look at your certifications and your approvals as now you've made sure that your vehicle is safe. What you've done here is you've made sure that you met the regional rules. That does not guarantee your safety. What you really want to look at is your item 1, your safety analysis and your plan, and item 14 there. That's how you're guaranteeing your safety. When you go through the different steps on item 15, depending on how thorough they are, what it really involves is them going through and reviewing what you did in item 1 and item 14. It all ties back together, it all makes sense. It's really an engineering activity with an outside auditor looking at it. So again, on the Dataspeed with our ByWire kits, which are a key part of the safety, we've been through these certifications. We have over 500 vehicles operating in the country, around the world. We've had safe certification from TÜV approval for operating autonomously on roadways, even in Germany. So to wrap it up, last slide, this is all of those steps put together. Again, I want to say this is not a complete list. It really depends on what the technology is, how you're testing it. But this is the basic, just overview, lessons learned, something to share with the community. And the last thing I'll add to it is to categorize it by where are the safety items, where are the rules from others, from the regulators and the authorities, and where's the technology part of it. And the function there is really the software part of it. So you can kind of see how everything fits together. You start with the safety, you end with the safety, and then you do a final certification if it's needed.